Hi, this is Asing. You are now watching Asing Math TV. Today, we'd like to share the inferences about the difference between two population proportions. Before we are able to conduct the exact test, we should first obtain the proportion for the respective population and hence obtain the pooled proportion. According to the question, we should test whether the obesity prevalence is about the same among females and males, and the keyword here is same, which means that we should conduct the null hypothesis that the difference in the proportions is equal to 0 versus the difference in the proportions is not equal to 0. At alpha equal to 0.05, we should take alpha over 2 since this is 2-2 test, and the critical value is supposed to be plus minus 1.96. To obtain the critical value, we can make use of SPSS or the standard normal table. Let's make use of SPSS since we have SPSS here. Make sure the data view is not empty, otherwise we are not able to obtain the result. Go to transform, compute variable. What we need here is the z-score. Numeric expression, look for inverse DF. What we need here is the normal distribution. Our probability is equal to 0.025 since this is 2-2 test. For standard normal distribution, mean equal to 0, standard deviation equal to 1. Click on OK and we should obtain the z-score. From here, we can see that we have negative 1.96. What we need here is plus minus since this is 2-2 test. 1 for the left hand side and 1 for the right hand side. Always less than the negative, more than the positive. Substitute the values that we obtain for each proportion and the pool proportion, and we should obtain the test statistics, which is negative 2.55303. Since the test statistics is negative, which means that we should compare to the left-hand critical value, which is smaller than. As we can see, this value fall under the rejection region, which means that we should reject H null at 0.05 significant level. Therefore, that is sufficient evidence to conclude that the obesity prevalence is not the same among the females and males. Unfortunately, we are not able to conduct that test for two population proportions by using SPSS since it's not available. However, there is an alternative available in SPSS, which is the chi-square test of independence. Recall the relationship between standard normal distribution and chi-square distribution. From here, we can see that as long as we conduct a 2-2 test under that test, it's equivalent that we conduct a chi-square test, provided that the degree of freedom is equal to 1. From here, we can see that we have 2 rows and 2 columns, which means that this result in degree of freedom equal to 1, and hence we can conduct chi-square test for this example. Let's try. At alpha equal to 0.05, the critical value, we have to bear in mind that for chi-square test of independence, we always take alpha instead of alpha over 2 since chi-square as the name square is always non-negative, which means that always right tail test. From here, make use of the SPSS, we are able to obtain the critical value. Compute variable. Target variable, we can type x, and we need the inverse df. Look for chi-square up. The first question mark is the probability or the level of significance. However, we should always bear in mind that SPSS always take less than cumulative. What we need here is more than cumulative, so which means that we should take the complement of this value, which is 0.95 with degree of freedom equal to 1. Press OK and we should obtain the critical value that we want. From here, we can see that we have 3.8415 rounded to the nearest 4 decimal places. Now let's compute the test statistics by using SPSS. To ensure that we obtain the correct result, we should ensure that all the values are input correctly. Follow this rule and we should obtain the correct result. Always remember to give a column for the frequency, which is the observed value or the numbers here. Secondly, we need a column for each variable, which means that we need 2 columns here, one for obesity, one for gender. And we can go to variable view to define obesity and gender. According to the obesity, we have 2 groups. One is yes and one is no. Simply let 0 be yes, 1 be no. And so for the gender, 0 for female and 1 for male. First, enter the frequency. We can enter vertically or horizontally. I will always follow horizontally. So first 132, followed by 182, followed by 348, followed by 338. Next, opacity. Refer to the value that we have, 132. 132 belongs to yes, which is 0, and we should type 0. And the gender here is also 0 for female. Next number we have 182, which is 0 for yes, 1 for male. So we have 0 and 1. Next we have 348, 1 for no, 0 for female. We should enter 1 followed by 0. And for the last value we have 1, 1. After finish entering, we will now be able to compute the test statistic. Before that, always remember to weight cases since we have frequency here. Go to data and look for weight cases. We should weight cases by frequency. Click on OK, and all the cases should now be weighted by frequency. Proceed to analyze, look for descriptive statistics, crosstabs. If we want to have exactly the same orientation as this table for our crosstab, remember that up, down means that rows, left, right means that columns, which means that we should put obesity under row, gender under column. Go to statistics and check chi-square distribution, chi-square test. Click on continue, go to cells and check for expected value. Click on continue and click on OK, and we should obtain the result that we want. From here, if let's say we want to increase the number of decimal places, double click on the table, select the numbers, right click and click on cell properties. Go to format values and increase the decimal number. Click on OK and we should have 4 decimal places. As you can see, the expected value that we obtain is exactly the same if we compute it manually. And now from here we obtain the test statistics is equal to 6.518. If we need 4 decimal places, also double click the table, right click the value, look for cell properties, and we choose 4. Click on OK and we should have the number. If we take the square of the test statistics obtained under that test, we should obtain exactly the same value as compared to the test statistic obtained under chi-square test. From here, we could also conclude that we reject H null at alpha equal to 0.05 since the test statistics is greater than the critical value. And therefore, we can come to the same conclusion. And for the p-value approach, also right-click the number, cell properties, go to format value and increase the decimal point if needed. Although stated clearly, this is two-sided. We should always bear in mind that the value that computed under Pearson chi-square is only for one tail, which is the value that we need here. Supposedly, when we see 2 by 2 contingency tables with degree of freedom equal to 1, we should conduct the continuity correction. However, we should always bear in mind that this correction might be overcorrected, which means that it's not necessarily for us to conduct continuity correction. So we will still allow to take the p-value that computed under Pearson chi-square. From here, we can see that this value is less than the significant level and we should reject H null at alpha equal to 0.05. Therefore, we should come to the same conclusion where we can conclude that there is sufficient evidence to say that the obesity prevalence is not the same among females and males. Okay, that's all for this video. Thanks for watching. Hope you like this. See you.